This opening slide introduced Windows Digital Forensic series. It set the theme, Foundation of Windows DFIR, that is Digital Forensic and Incident Response, with the emphasis on investigation mindset, the window artifact map, and a starter toolkit stack. Later modules go deep on the NTFS, execution evidence, registry use activities, and event log timeline. For example, framing if ransomware hit a finance laptop last night, Module 1 will teach how you can think and what you can collect first before you memorize every fetch flag. This slide defines measurable outcomes so learner knows what done look like. After this lecture, you will be able to explain what is DFIR purpose, separate live versus dead box analysis, name major artifacts families, follow a workflow, and list practices tools. The practice goal blocks pushes them towards a personal lab checklist that is acquire, parse, timeline, and report. For example, a junior analyst who can only open Autopsy randomly should leave able to say, I will image with FTK imager, hash the E01, parse MFT with MFTE CMD tool, and review the CSV in Timeline Explorer. Windows Digital Forensic is the scientific reconstruction of user and system activities from Windows host using disk, memory, and logs to analyze who, what, when, and how. The right side flowchart, which include the question, artifacts, timeline, and conclusion, is the mental model for every case. Use cases include IR, insider investigation, malware, ransomware, and legal HR support. For example, after a phishing click, question did payload.exe run, drive artifact selection, prefetch and mcache tools, which feed a timeline which support the conclusion that execution occur at a specific time. For example, 14.07 UTC hours. This comparison diagram shows two complementary approaches. The live response captures volatile state, for example, RAM processing network with tools like KAPE or Velociraptor. When speed matters on malware may be memory only. Dead box analysis works from a disk image like E01 VHDX, and persistent artifacts include registry, MFT, Prefetch, EVTX using Eric Zimmerman tools, and Autopsy. For example, for an active C2 backend, dump memory first live. For a historical who deleted payroll Excel last month case, a write blocker disk image is usually enough and more code friendly. The hub and spoke diagram maps 5 major window evidence domains around the host: NTFS, MFT, execution artifact registry, event logs, user and user activity. Investigators should never rely on single artifacts. Corroboration is the standard. For example, Prefetch may show winword.exe ran, LNK recent docs may show the document path, MFT may show the files MACB times, and security EVTX may show the user logon that precede editing together. They tell a stronger story than Prefetch alone. This vertical flowchart is a repeatable case method that includes the scope and legal authority, preserve with hashes, parse key artifacts, build a super timeline, hypothesize and validate with indicator of compromise, report finding and coincidence, for example, scoped to one workstation after a leaked spreadsheet, preserve via E01, parse MFT, perfetch USB store, timeline shows USB insert that copy of the confidential Excel file, and validate with the shellbacks LNK. Report includes UTC times, evidence paths, and residual risk that other hosts were not examined. The decent volatility paradigm explains why collection order matters. CPU cache and RAM vanish first. Disk can back up last. Shutting down too early can erase fileless malware or decrypt keys only present in memory. For example, if an analyst immediately power off a compromised server to preserve the disk, they may lose a running PowerShell implant that never wrote a durable binary memory acquisition. With tools such as WinMem dump IT, then volatility would have been the better first step when legally and operationally allowed. Evidence integrity and chain of custody. This horizontal pipeline identify, acquire, hash, analyze, copy, document, reinforce forensic hygiene. Always prefer working on hash forensic copies, record custodianship, and node tools version command. For example, imaging. Um, Physical drive 1 to case 2026 E01. Computing SHA-256, verifying the hash after transfer to the analysis workstation, then parsing only the verified copy with MFTE-CMD tool. So defense counsel cannot claim the evidence was altered during analysis. This table is the practical shopping list for a skill practice. KAPE, Velociraptor for collection, Eric Zimmerman tools as the window parser suite, Timeline Explorer for CSV review, Autopsy FTK Imager for image browse, Volatility 3 for memory and registry, Explorer for hives, highlight the alter box tool, MFTE, CMDP, CMD, RECMD, EVTX, ECMD, LECMD, and Timeline Explorer. For example, lab task use KAPE target basic collection, then feed Prefetch to PECMD and EVTX to EVTX ECMD, open both CSVs in Timeline Explorer, filter to the suspect username. The 4-day path turns theory into muscle memory. Install EZ tools, mount to E01, parse MFT, answer a mini case question with Prefetch and MFT tools, then write a one-page report. The takeaway closes this part. Collaborator artifacts, respect volatility and integrity, use a repeatable workflow, and practice Zimmerman parser early. For example, success creations, a learner can demonstrate PECMD output showing notepad.exe last run time and point to matching standard information file name times from MFTE CMD for the same execution path.